Good morning, fellas. This is Mr. Vetro. We are going to continue with our Unit 11 unit, which is our last unit, the circular functions unit, which is our unit circle. Have your unit circle sheet out with all the coordinates and the radian measures because you're going to need that if you haven't memorized it yet. You can use your calculator a little bit to memorize the decimals. I'll talk about that in a little bit right now as we do this problem, all right? Remember, having calculators also, you want them in degree mode when you're doing trig. I think you all have that already. All right, let's go on with this lesson. The sine and cosine functions are the first a student typically encounters that are non-algebraic. That is, they cannot be thought of as combinations of a finite number of integer powers and or roots. Since they are defined by using the geometry of a circle, they are not all that intuitive. Additional practice will be given in this lesson to simply get used to them. All right. Recall the following definitions of the sine and cosine functions. If theta is an angle and drawn in standard position whose terminal ray passes through the point xy, blah, 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 then sine of theta is always equal to y. We talked about that. And the cosine theta is always your x. All right. When we do a point, that's how it works. Cosine is x, sine is y. Given the function f of x equals 6 sine x, which of the following is the value of f of 60? Well, we're just evaluating a function here. We're plugging in 60 in for x, right? What's 6 sine of 60? What's the sine of 60 degrees? Now, if you had your unit circle out, all right, you'd see you're talking about this point right there, all right? Sine is the y value for it. And this point right here, the y value is radical 3 over 2. All right. I have it memorized. You don't probably. All right. What you can also do in your calculator right now, you could do sin 60. Just type that in. And you'll see a decimal. You'll see 0.866, blah, blah, blah. You could memorize this decimal. This decimal, 0.866, blah, 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 is radical 3 over 2. So if you ever see that decimal on your calculator, you know it's radical 3 over 2. If you see negative 0.866, you know it's negative radical 3 over 2. Anyway, now you know that. What's 6 sine 60? Well, what's 6 times radical 3 over 2? Well, remember, this cancels with this. This becomes a 3. 3 radical 3. There you go. All right, and there's your answer. Let's keep going. If g of a equals 4 cosine a minus 2 sine a, then what's g of 330? So we're just plugging it in. 4 cosine of 330 minus 2 sine of 330. But what's 330 degrees? Well, let's look back over here. If you haven't memorized it, right? 330, well, this is 360 over here. It's right there. There's 330 degrees. They want to know what is that point there? Did you memorize it yet? I don't know if you did, but that point right there is negative 1/2, comma, radical 3 over 2. I'm sorry. Yeah, negative, I'm sorry. Screwed up. It's not that. Right there. All right. That's positive radical 3 over 2, comma, negative 1/2. All right. So that means our cosine is radical 3 over 2. So 4 times radical 3 over 2 minus 2 times, but the sine is negative 1/2. That's our y value of our coordinate. So if you do this math, what do you get? Well, here we go. That's 2 radical 3. These 2's cancel. So it's really 2 radical 3 minus a negative 1, which means plus 1, right? Choice 3. Okay. Size 4. Which of the following is not equal to 1? Well, let's think about it. You could plug it into your calculator, or 0 degrees is right there. What's the cosine of 0? What's the x value of 0? Well, the x value of 0 here is 1. That's the unit circle, right? So that's not it. Not equal to 1, right? Well, the sine of 90 is right there. Well, what's the y value at 90? 1. So that's equal to 1. The cosine of 360 is right there. It's the same thing as the cosine of 0, right? Same thing. That's not it. 270 is right there. The sine of 270 is negative 1. That's not equal to 1. So there's your answer. For angle A, whose terminal ray lies in the third quadrant. All right, now that's important. Remember, all students take calculus? So third quadrant. All right. Just keep that in mind. We don't need it now, but it says tangent is positive here. All right. So if tangent is positive here, tangent is equal to, if you remember, I don't know if you know this, but tangent, I don't know if I taught you this. Tangent is equal to sine over cosine. Opposite over adjacent. Sine over cosine. So if your cosine is negative, they want to know what's the value of sine. Well, if tangent is in the third quadrant, if this is in the third quadrant, all right, then sine has to be negative, because if cosine is negative, a negative divided by negative is going to give you a positive. Tangent has to be positive here. But you don't need to know that right now. It's just good to know in the future. They tell us the cosine is negative 0.96. What is the value of the sine A? So remember, we did the Pythagorean theorem with this. So you say negative 0.96 squared plus, I guess, sine, let's erase this, plus sine of A squared equals 1. That is the first identity we talked about last week. All right, the Pythagorean identity. So negative 0.96 squared. I like to go to 4 spots when I'm doing trig. 0.9216 plus, I'll call this x squared for now, equals 1. 1 minus 0.9216 gives you x squared, or sine A squared, equals 0.0784 is what you should get. And now I got to take the square root of that, all right? And you'll get 0.28. But then you might say to yourself, well, why is it negative? Well, it's negative because it's in the third quadrant, all right? And in the third quadrant, all students take calculus. Sine is only positive in the first and second quadrant. It's negative in the third and fourth quadrant, okay? So they said it's in the third quadrant, therefore it's negative. You gotta be careful about that, okay? Okay. Exercise 6. In each of the following, an angle and its reference have been given. Using your calculator in the degree mode, determine the sine and cosine of both the angle and its reference. Round all answers to the nearest 100. All right. So here's what we got to do. The sine of 110 in our calculator, do it in your calculator. Just press it in. You'll get 0.94. And the cosine of 110, if you do it, you'll get negative 0.34. Well, if you did sine of 70, what happens? You get 0.94. And if you did cosine of 70, you get 0.34. Matches up. Matches up. Pretty cool. Let's see if it works over here. Sine of 235 is negative 0.82. The cosine of 235 is negative 0.57. Just getting it right from my calculator. Well, what do you think the sine of 55 is going to be? But you got to be careful here. Watch, the sine of 55 is going to be something with this, but it's actually 0.82 because it's in the first quadrant. All right. So the quadrants matter with their signs. All right. So you got to be careful about that. Cosine of 55 is going to be positive for 57 because in the first quadrant, right? 55 degrees in the first quadrant. Cosine is positive. So stuff like that you got to be careful about. All right. Sine of 282. Well, the sine of 282 in my calculator, I get negative 0.98. The cosine of 282, I get 0.21. The sine of 78, though, is 0.98 because, once again, it's in the first quadrant. All right, so it's going to be positive. and the cosine of 78 is the same thing because positive. All right, so there we go. It's just all calculator work, checking out the relationships between our angles and reference angles. Because clearly, the absolute value of the sine and cosine are the same for its angle and its reference. Makes sense, right? The absolute value is the same. This fact can be exploited to produce sine and cosine values. Given that cosine of 30 is radical 3 over 2, and sine of 30 is 1/2, determine the following values in exact form. Okay, cosine of 150. All right, so here we go. We got to come up, all right? I like to call this coming up with its reference angle. You got to come up with its reference angle, right? So the cosine of 150, what is that? What is its reference angle? Well, its reference angle is 30, all right? But, all right, so the cosine of 150 is the same thing. Where's 150? 150 is in the second quadrant, right? So cosine is negative there, right? So our answer's got to be negative. And what's the cosine of 150? Well, if you look the exact value for that, it's the same thing as the cosine of 30. And the cosine of 30, all right, is negative radical 3 over 2. Radical 3 over 2. So this is negative radical 3 over 2. The sine of 150, well, its reference angle is 30, right? But 150 is in the second quadrant, and it's positive. Therefore, my answer is going to be positive. So it's just 1/2. That's our answer. Sine of 30. So that's equivalent to the sine of 30. This is equivalent to the negative cosine of 30. All right. Cosine of 210. Well, 210, all right, is in the third quadrant. Cosine is negative in the third quadrant, so I'm going to get a negative answer here. Well, what's 210 equivalent to? That's equivalent to the reference angle here is 30 degrees. So it's negative cosine of 30, which is negative rad 3 over 2 again. The sine of 210, all right? Once again, that's in the third quadrant. Sine is negative in the third quadrant, so I have a negative answer here. All right? What's my reference angle? My reference angle is 30 degrees again. So what's the sine of 30? 1/2, so it's just negative 1/2. Negative sine of 30. Because the quadrant has to, you get pay attention to that quadrant. The cosine of 330, well, 330 is in the fourth quadrant. All students take calculus. Cosine is positive in the fourth quadrant. So my answer is going to be positive here. The cosine of 330 is the same thing as the cosine of 30, which is radical 3 over 2. The sine of 330 is going to be, sine is negative in the fourth quadrant. So our answer is going to be negative here. The sine of 330 is the same thing as the negative sine of the reference angle, which is 30, which is 1/2. So it's negative 1/2. All right. Now, like I said, if you memorize the decimals of the trig functions, you could type in letter A here, cosine of 150 in your calculator. You'll get negative 0.86666, blah, blah, blah. You can say, oh, that's negative rad 3 over 2. That's up to you, though. All right. All right. Exercise 8. Evaluate each of the following trigonometric functions. Well, first we have to come up with the degree measure. So you could multiply this by 180 over pi for each of these and get the degree measure. So you might want to pause the video and do a little side work, but this is the sine of 90, all right, which is just 1. To get the unit circle, sine of 90 is the y value, which is 1. Sine of this winds up being 60 degrees. The sine of 60 is radical 3 over 2. The cosine of this winds up being 270 degrees. Cosine of 270 is 0. And the cos at 3 pi over 4 winds up being 135 degrees. So the cosine of 135, that's a 45 degree angle. That's right over here. I'm sorry, it's right over here. All right, and if you look at that's our negative radical 2 over 2, radical 2 over 2. So this is negative rad 2 over 2.